Today we're going to be learning about multiplying and dividing rational expressions all together. So we need to make sure that we're simplifying inside the parentheses first because of order of operations, and then we're going to complete multiplication or division from left to right. It doesn't matter which one comes first in the question. So the first one that we're going to talk about is this. We have 3a to the fourth divided by 2b to the fifth times 2b squared divided by 6a to the third, all divided by 10a over 5b to the fifth. So in this question, since there are no parentheses, we're going to go ahead and work on doing everything all at once. That means that our multiplication fractions can stay the same. And then our division fraction, remember, we're going to flip it and multiply. So now we're going to work on crossing things out that can simplify. And there's a number of ways that you can do this, but I noticed that 3 and 6 would give me 1/2. And 2 divided by 2 would go away. That would give me 1. And 5 divided by 10 would be 1/2. That means right now in the denominator of this we have 4. I have b to the fifth and b to the fifth. Those go away. And in the denominator, I have a to the third and a, so that means we have a to the fourth. So both of those can go away with the a to the fourth in the top. That means all that we have left in the numerator is b squared, and in the denominator, 4. So there's the first part of our answer. Remember, we still need to find restrictions. And for restrictions, we need to look in multiplication at the denominators, and in division, the denominator and the numerator. So that means that for all of these, we have just monomials. That tells us we're going to have a can't equal 0 and b can't equal 0 for our restrictions. Our next question is where we're going to have to factor and do a little bit more. So for this next one, we do have some division going on. We actually have two things of division. 2a minus b over a plus b is being divided by 3a plus b over 2a plus 2b is being divided by 8a minus 4b over 9a squared minus b squared. So we're going to flip these fractions since they're division, and we're going to work on factoring as we go. So there's nothing to factor in the first question. In the second one, remember, we're going to flip this, and there's a 2 GCF in the denominator, which now becomes the numerator. There's nothing to factor with that 3a plus b, so we're going to leave it alone. And again, we need to flip this fraction as well. So when we flip the 9a squared minus b squared to the top, we're going to factor that into 3a plus b and 3a minus b, since it's a difference of squares. 8a minus 4b has a GCF of 4. So that's going to leave us with 2a minus b left inside. Now that we're here, we can either choose to write restrictions, or I'm going to cross things off first. So we have 2a minus b's, those go away. A plus b goes away. 3a plus b goes away. And 2 and 4 would give us 1/2. So the first part of our answer is 3a minus b all over 2. For restrictions, we got to be really careful with this question. We need bottom, bottom, top, and bottom top of that third fraction because of the division pieces. So for our restrictions for this question, since we have more than one variable, we are going to solve for the first one alphabetically. So that means we're going to solve for those a's. So here we would have a can't equal negative b. This one would give us that a can't equal negative b over 3. We already have negative b as a restriction from this. This 2 is just a GCF. It doesn't have a variable with it, so there is no restriction there. Our denominator here would give us b divided by 2. We already have the negative b divided by 3 from over here, and this one would give us positive b divided by 3 for restrictions. You could combine these two together and make it be plus or minus b divided by 3 if you wanted, or you can leave it like this. All right, let's take a look at an example that has more factoring that needs to happen in it. Another way that you can choose to do these questions is kind of factor everything first and then flip things. So we're going to still work within the parentheses here. And here's another thing you can do. Some people like to just factor these pieces right there by the question. So here we would factor 2x squared minus 9x plus 10 into 2x minus 5 and x minus 2. X squared plus 4x plus 3 would factor into x plus 3 and x plus 1. I'm going to flip these as I'm factoring since it's division. So I'm going to flip this one up. That means that we're going to factor this into 2x plus 3 and x plus 3. And 6x squared plus 11x minus 10, I'm going to flip down here and factor into 2x plus 5 and 3x minus 2. Now you can choose to cross things off at this point if you would like. It's probably going to make things a little bit cleaner for us, but the only thing right now that crosses off is the x plus 3's. Okay? And I'm going to start finding our restrictions here before things get too messy. So we need bottom, bottom, top for the restrictions. So we have x can't equal -3, -1, -5/2, positive 2/3. Oops, and that's going off the screen for y'all. -3/2, and then we already had -3. All right, so now we are going to factor this first fraction. So we're going to factor the numerator into 2x plus 3 and x minus 2. And the denominator is going to factor into 3x minus 2 and x plus 1. And then this, what we have left, this becomes one big fraction together. Since we had multiplication, we're going to flip that entire fraction since it's after a division sign. So that means that we're going to have x plus 1, 2x plus 5, and 3x minus 2 flip to the top, and 2x minus 5, x minus 2, and 2x plus 3 flip to the bottom. So then we're going to start crossing things off that we can. So 2x plus 3 can go away, x minus 2 can go away, x plus 1 crosses off, and 3x minus 2 crosses off as well. So the first part of our answer is 2x plus 5 over 2x minus 5. And then we just need to make sure if there's any other restrictions that need to happen. So we need bottom, bottom, top. Remember, we kind of already found all of these pieces and restrictions, but we'll just double check. So we need 2/3, -1, positive 5/2. So we need to make sure we write that down. Positive 2, -3/2, positive 2/3, -5/2, and -1. So we've got all of our restrictions there, and we're good to go. So there's the first part of our answer, and we have 6 restrictions for this question. All right, let's take a look at one last example. This one's going to have the most amount of factoring. So again, we're dealing with parentheses first, so we're going to stay within here first. Now, if you notice, a lot of these have GCFs to factor, so I'm actually going to factor those GCFs out first. So the numerator here, for 6x squared minus 28x minus 10, we're going to take out a 2. And down here with 12x squared minus 30x minus 150, we're going to take out a 6. These are going to flip because it's division. There's no GCF, so I'm just going to write that 4x squared minus 21x plus 5 up there. And then in the 8x squared minus 36x minus 20, we're going to take a 4 GCF out. And so that would give us 2x squared minus 9x minus 5. All right, so now we're ready to deal with that part of it and factor it even more. So again, we're ignoring this last part at the current moment. So we're going to have 2 The inside piece is going to factor into 3x plus 1 and x minus 5. In the denominator here, we have 6 as a GCF. The inside factors into 2x plus 5 and x minus 5. The numerator is going to factor into 4x minus 1, x minus 5. And the denominator is going to factor with the GCF of 4 out there into 2x plus 1 and x minus 5. Okay, so now we're going to cross things off here. So x minus 5, x minus 5. Here, 2 and the 6 become 1/3. You could have also done 2 and the 4 to make 1/2. You're going to multiply them in just a second anyways. All right, before we lose sight of things, I'm going to write my restrictions over here. So we need bottom, bottom, top. Bottom, bottom, top here for restrictions. So we have x can't equal -5/2, +5, -1/2, +5 we already have, and +1/4 for restrictions so far. We're going to keep all of this the same in a fraction together. So we have 3x plus 1, 4x minus 1, over 3 times 4 gives us 12. And then we have the 2x plus 5 and 2x plus 1. Now this fraction over here, we do need to take and flip. And then we also need to work on finding GCFs of those pieces as well. So there's no GCF here, but that is going to come down to the bottom. And in the denominator, that's going to move up, we can take a 3 GCF out. So that would leave us left with 4x squared plus 12x plus 5. All right, so that fraction, when we factor it, the numerator has a 3 GCF, and inside we have 2x plus 5, 2x plus 1. And in the denominator, we're going to factor that into 3x plus 1, 4x minus 1. Last step is to simplify out whatever we can. So 3x plus 1's go away, 4x minus 1's go away, 2x plus 1, 2x plus 5. We have these monomials, so 3/12 is going to give us 1/4. All of that at the beginning ended up being a super nice answer in the end. Now we need to double check for restrictions. So again, we had a division question, so we need bottom, bottom, top for this. So we have -2/5, -1/2. We need to add -1/3 to our restrictions over here. We already had 1/4, -1/2 again, -5/2, and that doesn't have a restriction. So those would be the end of your restrictions.